Good afternoon, everybody, and thank you so much to Carleen and Bridge for inviting us to share some of our research. The presentation that I'm giving is on behalf of both the University of Witwatersrand and JET Education Services, and it relates to error analysis in conjunction with the ANA. So both of the presenters have actually spoken to us about using the ANA diagnostically, and I'm glad to see that because I wasn't necessarily sure that that would come through having read their synopsises of their presentations. My presentation looks deeply into that in a little way from a more academic point of view, but I think that all of the teachers present here will benefit as well from what we have learned in terms of two research projects on which this presentation is based. So the background, which I think most of us are fully aware of, is that ANA is now part of the scenery of school education, and that all of us have to participate in that no matter what we think about it. The idea that the ANA is there to be used to judge teachers is felt quite strongly. I think both presentations before myself have been positive in looking at the view of that ANA can be used by the teachers for their own purpose. And in fact, that is part of the plan, that ANA was set up not only to give an assessment of what's happening in the schools, but it was set up so the teachers could use it diagnostically within their own classrooms. So part of the 2014 aims state that the ANA gives examples of assessment standards and methods, a goal towards which teachers can work, to enable better targeted district support, to enable the evaluation of school performance. We know that, as both presenters have said, there's some teachers doing a fantastic job, and in fact that should be, ANA can validate that for you. And then we do feel frustrated by teachers that are in our schools that are not performing in the way they should, and in some sense there is some purpose in ANA exposing that, as it were, because we need our learners to be given the best opportunity. And I think that the ANA was set up in order to ensure that that opportunity is given. Unfortunately, I feel, and we feel from the research that we've done, is that a lot of the data is not used in that way. And the error analysis, we feel, can address that need, that teachers can use the ANA for their own purposes. So the guiding interventions, the broad purposes, and the provision of a system-level measure of learner achievement in key subjects. There are diagnostic reports issued centrally from the National Department, and guidelines are given on how to interpret the ANA results at different levels of the system. The guidelines are quite specific, as with the marking memos, and yet within that there's, we feel, not sufficient support for teachers to actually take up the diagnosis. Ultimately, when the report comes out, it's very broad, and it gives very broad suggestions for teaching. So that minute analysis of what's in the ANAs and where we can learn about the little things that children know and don't know, or learnt and haven't learned, that doesn't come through from the broad diagnostic reports that are issued. What we have found in our research is that the effective use of this data actually requires high levels of expertise on the part of the teachers. The teachers do administer and mark the assessments. There are problems in that regard. We are aware that certain teachers are very, very careful and do the job properly, but we also know that because of the pressure that is there on the back of you in terms of what you get in your ANA, that sometimes teachers don't necessarily mark accurately or according to the memo, and that is a big problem. So the data is meant to be valid and reliable, but there is a question mark over some of the ANA data, which is why they've set in process the validation ANA and things like that. The items should be linked when you're doing this analysis to the specific skills, knowledge, and concepts of each of the items in the test, and teachers should be able to interpret the learner responses. One of the speakers referred to that the memo is set out and it's very, very clear, and then if a learner goes a different route, sometimes the teachers don't really realize that that alternative route is acceptable. So it's a dangerous thing. It's both a good thing and a dangerous thing that the ANA memo is as clear as it is. And alternatives definitely need to be thought about. And often when people set up a memo, they cannot possibly think about all the different routes that the learners might take. The ANAs should be used to provide relevant and constructive feedback. It isn't necessarily done, especially with the time pressures of the curriculum and the time of year in which the ANA is set, and also because of the way in which teachers are preparing for the ANA. They're not necessarily thinking about it like that. They haven't been given the skills to use and interpret the ANA. And so the hardest thing of all, which would be used to use the ANA to adjust the teaching, it's not really often seen in practice, because once it's been done, administered, and you've submitted your marks to the department, you breathe a sigh of relief and continue with business as usual. So the ANAs are there. This is wording from the document. They provide regular, well-timed, valid, and credible data, and they are meant to be used for diagnostic purposes. Now, our research, we acknowledge that teachers have always needed to recognize learners' errors. We need to analyze learner thinking, and we can use something like the ANA or any test to question what the learners are thinking, what they're saying through what we see, what they write. But the actual requirement that teachers should interpret their own learners' performance in the national and other assessments is written in the government documentation. And so what we looked at is ways in which teachers could be equipped to do that proper diagnosis. So the JET pilot project took scripts not from the ANA, but ANA similar tests to the ANA, which are open-ended, majority open-ended, and you get learners writing their own answers, which you then as a teacher have to analyze. What we found, a quote from Sarah Bansalal in UKZN, is that the ANA, the opportunity for improving learning lies in the capacity of the department to support the districts and teachers to take up what's in the ANA. So we've heard a lot of positive talk about doing that diagnosis, but as teachers, I'm not sure how many of you have, those of you that are teachers here, how you've used the ANA and if it has been possible for you to use it diagnostically. The idea of using tests diagnostically is relatively new, but it is getting older. And we're seeing more and more where the difficulties are in this field and which things teachers find more easy. So what have we done and what have we found out? We found out that to generally identify the skill being tested is not a complicated thing. The curriculum document, I also feel, is a very powerful document. The maths one in particular is strong, it's clearly laid out, and the sequential development of the concepts in that CAPS is very, very good. But that being done, the ability to say, okay, what's being tested? Look at my curriculum, yes, it's on the level, everything's fine, that works. But to take it further and try to look at the hierarchy of skills, the teachers that we've worked with have found that a difficult thing to do. Because what happens, and that's because of the pressure of the ANA, is that teachers focus on the overall results and the trends, and they don't go into that small detail of particular answers which are found in the scripts. And also, although this leaning through continuous assessment and that kind of thing in assessment in schools, something which we heard a lot about when we were in the outcomes-based education time, to move away from a focus on what is right or wrong. But in maths, we still find that teachers ultimately focus on right and wrong. Because it's an easy thing to do. It's easy to say, yes, you're right, no, you're wrong, and not to worry about those bits in between. How far am I right? Where did I go wrong? Teachers still tend to focus on a tick or a cross, and that's done. Because it's a big job, you've got a heavy load, and so on. We find that teachers struggle to interpret the level of understanding. It goes into going deeper, and it's a difficult thing to do. It's easy to say you should do it, but actually doing it is hard. Again, struggle to interpret partial understanding and alternative methods. That goes to the variation in answers which are possible, looking to what is right and what isn't right and where did it go wrong. That's a difficult thing to do. It's much easier to say it went wrong and forget about it. And the most difficult thing of all is to say, okay, I've seen these things, I've seen that this is going wrong, but to then incorporate that in a plan to adjust your teaching to fit that in, that we've seen teachers find it very difficult to do, and we don't see much of it happening in the classrooms. So what is error analysis? I think certainly the first speakers referred to it. I don't remember if the second one did. Error analysis analysis, people are speaking about it a lot, and it's mentioned in the framework documents and that kind of thing. It doesn't only focus on the errors. It focuses on the whole question and the learner thinking around that question. And before you go into looking at the errors, you actually look at what the question was asking and what you need to do in order to get it right. You can then look at partially correct and also incorrect methods of solutions. The reason why it's useful is because a lot of the errors will come across in many of the learners in your class's work. And so if you do that analysis, you'll start to get a sense of what are the common errors in my classroom, which are the common misconceptions which I need to address. If learners are thinking a particular thing, maybe it's because of something that I did or didn't say, or maybe I need to add to the teaching on that particular concept. So it's a very, very useful activity to take out, and it needs to be taken out carefully in regard to every single concept which is being tested. So the broad ANA diagnostic report, which reported on the 2013 ANA that fractions are problematic and teachers need to expand on their teaching of fractions, doesn't really say anything about what actually went wrong and what actually should be addressed. But the teacher can look at every item and can look at the learner's responses, and I've got one item that I'm going to show to you later, where you can see how, in the way in which learners responded, you can adjust your teaching. Research has shown that a focus on errors as evidence of reasonable and interesting mathematical thinking on behalf of the teachers helps the teachers to understand learner thinking and to adjust in ways in which they engage with learners, and then to adjust their teaching approaches. So the theory is good, it's strong. The error analysis can and does impact on teaching, but only if you know how to do the error analysis. So why should you do it? The DIPPER project, which is a project that was carried out at Wits over a number of years, and there's still some schools in Gauteng where DIPPER is being worked on as a teacher development project in schools, looks at using tests as an artifact for a structured learning opportunity. So in the DIPPER project, we've very, very systematically and carefully developed a way of doing error analysis. And the reason why we do that is because we've seen that, as I've said, error analysis helps you to think not only about misconceptions, the errors, but the conceptions. So the two things in maths go hand in hand. And maths educators have always thought about right things and wrong things, and how the learning goes through finding something maybe difficult, not being sure how to do it, doing it in a slightly wrong way, and then honing that way of thinking and developing your mathematical conceptual understanding. So that the teacher then uses that to adjust their teaching. So the error analysis activity template, which I thought would be useful for teachers to take away with them, and this slide presentation is available with all of the others, is really very simple, but it has to be carefully and systematically done. The first thing to do is to take each item and you study the item. You take your curriculum document if necessary and look at that and see what is the concept that is being tested. Then the next thing, and this is the very difficult thing if you're using the ANA for instance, because that's an open test. You have to look at all of your learner scripts, that's your data in relation to the item. So the data that you get is your learner's work. If you're a teacher, learner's work is your data. That's what you study to see what's happening in your classroom. Higher up than that, you could give percentages of your achievement of your learners on the ANA, and that becomes the data for the principals or those assessing the schools in your area. Your data that you're most interested in is every single item answer that your learners gave. And what you start to do if you've got an open-ended test is you have to sift through the scripts and see what kind of answers are the learners giving. Then you can start to see a lot of people are using, for example, a horizontal method of calculation, but they're not breaking down the numbers correctly. And you group those scripts together. If it's a whole mountain of scripts, you know that this is an issue you have to address in the whole class. If it's only one or two learners, you know that you might want to take them aside at a break time and address it if it's serious and you think that that learner is capable of getting it right and you want to address that, with a view to your being a teacher who's trying to meet the needs of every child in your class. Now, when you look at those wrong answers, so you decide, okay, they're having a problem with the horizontal method of adding. You look more closely even than that, and you see what could they have been thinking when they did it. So if they're getting it wrong, why are they getting it wrong? The fundamental belief in error analysis in maths is that learners are trying to get it right. So when they write something, they are not being flippant and writing something that is there just for the purpose of being wrong. They actually believe in their answer, we assume, and they're putting it forward as their best attempt. So if that's their best attempt, what was going through their heads when they wrote that? Why is it not coming out right and getting to the right answer? And if you can try to get into their heads and try to understand where they were going wrong, you can start to address the things which they were thinking when they were getting it wrong. Now sometimes, and if you're the teacher and it's your manuscripts that you're analyzing, you can't even imagine what the child was thinking. But you've got the child in your class and you can speak to the child and say, what was going through your head when you wrote that? Why did you write that? And don't try and answer for them, let them answer you. And listen to their answer and start to see how it fits in with the way in which the concept should be addressed, the solution should be worked out. All of this thinking then could address, you could think about an activity for teaching. So all of this thinking has gone around looking into learners thinking around an error with an ultimate aim of how would it address your classroom teaching, and so you could plan an activity. So this is a little activity template that teachers could do and use in their schools to do error analysis in relation to the ANA items. And you can do it not only in relation to ANA, but in relation to any test. And then it would really start to influence your teaching and hone it to the needs of your learners. So here's an example of a script from the test in the project in which Jet worked, doing error analysis. I chose this example because it was interesting in the learner work that you see there. I'm sure that you all would admit straight away that what the child has written here does not in any way start to look as though it could possibly help the child to work out 3-digit addition, subtraction, or the multiplication in the last question. So what we needed to look at then in this project that I worked on with Jet, we were looking at learner strategies, and the particular strategy of using unit counting is very problematic and still prevalent, not only in the foundation phase, but right through into the intermediate phase. And this is a grade 3 level where 3-digit numbers are being used. So already it's completely inappropriate. Counting, using unit counting is inappropriate. And yet in the scripts which we analyzed for this, there were many, many learners that used the unit counting method. So on the right-hand side, I've given you the data. Now this was found by looking at the learner scripts. You can see there that on this item, in the schools that participated, only 14.7% of the learners got the first, no, this is the second one that I've given you the data for, the 374 minus 127. So 14.7% of the learners got that correct, okay? That's a very low percentage, I'm sure we all agree. Now what we say from the DIPPER perspective, from the working with errors perspective, is okay, put that in your back pocket, that's what happened in your class, 14% of the learners got it right. Now, look and see where did it go wrong. Don't moan and groan and worry, because that's not actually going to take you anywhere. Look at where things have gone wrong and take it forward from there to make it right. Now, what often happens in tests with operations is that learners add. That's the thing they do. They see an operation question and they add. So that's a simple error to iron out. Well, maybe not so simple, but it's something you can address. If learners added, you could ask them, why did you add? And then you could see, okay, they misread it. Or if you realize, well, adding's the only thing I know how to do, so when I do operations, I add, you know you've got a big thing to address there. Not a high percentage of learners did it there, but 2.9%. So there would have been a significant number there. Right. Quite a few learners subtracted, but they used the vertical algorithm incorrectly. So in sifting through the scripts, you could see that learners had subtracted, they had used the vertical algorithm, which strictly speaking, according to CAPS, is not actually allowed in grade 3. They had done it, and they did get the answer, they got the answer wrong. But what we notice about those kind of answers, and I haven't got one of those for you there, is that there's some intelligible work that you can address. So if you are starting to use a numeric algorithm, what we want to say is that that's a good thing. Drawing little circles or sticks at this level, it's inaccessible. You can't actually start to address it. You have to start showing numeric working, start to show whether your misunderstanding is at the level of tens, hundreds, and thousands, or the algorithm, or whatever it is, because there you can start to enter the working that the learner is presenting. A small group, but an interesting percentage, just rewrote the first number. So this for me is an indication that the learner wasn't certain. They tried to write something and they gave up. But that was part of what was there. That's the evidence that we found in these scripts. Now, the most worrying one is the other incorrect answers. So those were answers similar to the one that I've shown you, where you couldn't actually classify a mathematical error. And so a lot of learners in the schools that participated in this project actually had no idea how to attempt this question. That what they wrote down was unintelligible, and you couldn't really access it, and that's a huge worry. Only a few didn't attempt the question at all. So that was just an example. You've got to take your own learner work and do that for yourselves. What I would like to strongly propose, and what both our DIPPER project from Wits shows and the work with JICA through JET, is that teachers should be put at the center of error analysis in their own classrooms. They should be encouraged to carry out this activity, but they should also be enabled to carry out the activity. So something has to be done in terms of teacher development to make sure that teachers are able to do this diagnostic activity. So to possibly enable this, error analysis could be used in mediated forums, because what error analysis definitely could start to do in terms of the math teaching context is develop this thing that many people speak about, the pedagogical content knowledge. Not just I know how to add, but I know how to teach children how to add. I can understand the way learners think when they're doing addition. And very, very strongly, and this is something which I want to say in relation to Anna, we've got to move away from a compliance-based approach to a developmental approach. Now, the Anna, more often than not, I think more strongly at the moment, what happens with Anna is that it's reinforcing compliance. It's making teachers think I've got to teach to the test, I've got to, just fit in with the system and get the job done, rather than using it developmentally. Although that developmental use of the Anna was part of the vision of Anna when it was instituted as a systemic test in our country. Thank you very much.